Right, guys, so recording is going on. Let me kick off. So we're looking at DNS today. Some of you already know it. Some of you guys know some of it, and some of you guys don't know much of it. So let's just make sure that we're on the same level. Okay, so we're gonna have a quick look at what actually DNS stands for, what it is. We'll have a look at the hierarchy of DNS. I put together some example scenario. We're also going to have a look at how it works globally, the different DNS servers and propagation on the global scale. We're also going to have a look how the DNS request workflow works from when you type in a specific URL into your browser all the way to actually getting the page rendered in your browser, right? CDN, Content Delivery Network, that's something that we've just discussed prior to the call with Luboš there. And it relates to DNS somewhat, so we're going to touch on that. And the last thing is we're going to have a look at some online tools that are helpful when looking around for where a domain is registered, where it's hosted, where the emails are hosted, etc. So jump into it. First screen here. So what is a DNS? Domain name system is basically an internet phone book, right? The only reason why it exists is that people remember URLs much easier than they remember IP addresses, right? So if you wanted to, load Google, you don't want to type in the IP address, you want to go to google.com and get that translated to an IP address, and off you go. So that's the main reason for DNS existence. That applies to A records, which we all know, and that's what translates web address to a IP address, and the same applies to MX records, which is exactly the same thing, just for emails, because obviously emails can be hosted on other server than the web server for the website. Some DNS records can also translate domain name to other domain names, which then results in an A record lookup. So you can use a CNAME record to tell the internet, okay, example.com is the same as example2.com, in which case your browser is going to ask the internet for the A record of the example2.com, right? And TXT records we also know about, that just adds a additional information about the domain. We are using that, for example, when we want to, for example, when we're buying, when we're purchasing an SSL certificate, the authority that is that we request a certificate from needs to make sure that we actually have full access to the domain, and that we are either the owner or somebody who actually has access to the DNS. So they ask us to put some kind of a TXT, some random set of characters into the TXT record. They look it up, and that's how they confirm that yes we are what we say we are, or who we say we are. SPF record is a specific kind of a text record in a specific format. In the yellow line here is an example of it. And what that does is it tells the whole internet that they should trust these IP addresses and emails coming from them against the specific domain name. So if you put an SPF record like this against matrixinternet.ie, and then you send an email from address that is not here, then the recipient side of the emails can look this up. They can compare where the email is coming from and see that, okay, this looks dodgy. Maybe somebody is pretending to be someone who's not. So this is our way of telling the internet, trust these IP addresses or trust these domain names it's coming from. Sometimes you have, email account with Gmail or Outlook, so you can include domain name like this one. You can include a specific IP, or you can tell the SPF record with this A, you can tell them to use the A record as well, which means the server where the website is hosted. That's useful for contact forms, right? So whenever a website sends out an email, if this A is there, it means that we're telling the internet, try to trust this email, right? The way to get around this, as you know, is use a third-party emailing service like SendGrid or Sendinblue, stuff like that, in which case you should add the IP address of SendGrid here as well. And at the very end of the SPF record, you can see the -all. That basically tells the internet how to fail any IP addresses that are not mentioned in the SPF record, right? So the only distinction is the hyphen here. If it's the hyphen, then it's like a hard fail. It's telling the internet, you know, discard everything that is not coming from these addresses. And if you change this, the hyphen for the kind of a wavy hyphen, does anybody know the name of that thing? I'm not sure how it's called, but you know what I mean, right? Is it?
Tilde.
Really?
Tilde. Tilde.
There you go. That's what that is. So if you put that instead of the hyphen, it's telling the internet, you know, don't be as harsh to IP addresses that are not included here. And it's up to the recipient side how they approach it, right? Some setups, as you know, some of our clients complain that they are not receiving certain emails from, say, from the website, for example. So this is one of the things that we can have a look at. Make sure that there is either the A record or the IP address of the sending server or the IP address of the SendGrid, and make sure that the failing at the end is a tilde. Did I say that right?
Yep.
Good. That's one layer for ensuring email deliverability, right? And the other, a bit more deeper layer is DKIM record, which is basically also a TXT record, but it deals with encryption, private keys, etc. So it's kind of a deeper way of doing basically the same thing. Brian, you wanted to add some information to this one, didn't you?
No, you've got it covered with everything you covered on the TXT record anyway. There's not
Good.
really much there.
Good. Let's leave it at that then.
Yeah.
Okay, so a basic A record example is exactly what you see on the right side. A user types in the web address of the browser. The browser doesn't know where to go, what to do, so it's going to ask your DNS server, which is generally the DNS server provided by your ISP, your internet service provider. If you go to your ipconfig/all, you will see your local IP address. You can also see your public IP address. No, you can't, because it's just the local, but you can see the DNS servers, which are right here, right? So my browser is going to ask these two IPs, what is the IP of the google.com that I just typed into my browser? And the DNS server is going to return the IP to the browser, and the browser says, fine, I have the IP, I know who to talk to, and it's going to directly ping the web server of that IP and say, hey, I have information that you have a google.com page for me, can you send it to me? And it's going to send it over, and it gets rendered. So that's a very basic example of how that works. We're going to have a bit more, a bit bigger example later on. Okay, so just quickly fly through the hierarchy here. We have top-level domains, which is the .com, the .net, the .org, the geographic domains, the .ie, the .cz, .de, whatever. Second level is, oh, by the way, the top-level domains are maintained by specific organizations that are appointed by ICANN to take care of that, and that's not in our hands. Obviously, we are not responsible for anything there. The second-level domains, that's our responsibility, and the responsibility is delegated from these organizations to whoever is the provider, say Black Knight, who's hosting the DNS for Matrix Internet.ie, and Google, who's hosting the DNS for Google.com, right? And then, of course, we have subdomains, which is the same thing. You can have as many subdomains as you want. You can have whatever.google.com. So that's basically the hierarchy. Okay, what is next? There is an example scenario here. At the top here, you can see what I was talking about just previously. I'm actually going to switch to this now, so I can point. So the visitor types in google.com, and the browser will first. That's an important information here. This is how host file works. The browser will always check the host file first to see if there is a DNS information there. You know that we're putting the lines there to, for example, visit a website that we are yet to put live, so we can access it on the live URL without actually changing the DNS records. So host file is what changes the DNS just for us, right? So the browser will check the host file first. Is there a line for google.com? If yes, then I'm going to use the IP address from there. If not, then it's going to go through the A records in the DNS on the name server. Okay, and at the bottom, you can see kind of a bigger scenario of how complex of a setup there can be for your typical client, right? So say you are a client right here, or you're dealing with a client right here, and they went to GoDaddy and they purchased a new shiny domain name for their new e-commerce shop, right? So they bought myshop.ie. So what GoDaddy does, it registers the domain with IDR, or we are, as we know them now. We are taking care of the .ie, of course. So they are the appointed authority over that root domain, right? So fine, in the GoDaddy account, the user can log in, and they are provided with the domain name and with the name servers, and also with DNS panel, right? For whatever reason, they can move over the DNS hosting to any other DNS hosting in the world. For example, they can decide that, oh, I'm going to host everything with Black Knight. I will keep the domain registration with GoDaddy, but DNS moves over to Black Knight. That's fine. They can do that. They create an account in Black Knight, log in, they go to the DNS section, they prepare all the DNS records that they need, and then they go to back to GoDaddy and change the name server records, which are these guys, and they're gonna change them to ns1.blackknight.com, ns2.blackknight.com. That tells the internet that Black Knight is now responsible for the DNS of the myshop.ie domain name, right? Fine. Next, they are hosting an email with Gmail, and they are hosting a website, say, with whatever, AWS, right? So you can see that they can have the domain with one provider, they can have the DNS hosting with another provider, they can have their email with another one, and they can host the website wherever they want, right? So that's basically the most complex scenario, without getting into, you know, subdomains and other weird services that they might come to. One thing I wanted to touch upon here is a TTL. You may have noticed that whenever you're creating a new, for example, a record, whatever record it is, they always have TTL setting, time to live in seconds. And basically what that does is it tells the internet to cache this specific DNS record for that long, right? So if you set it for an hour, all the DNS servers around the world will remember it for up to an hour. And whoever requests DNS from their local server, for example, in America, someone wants to visit the myshop.ie, they type it in their browser will ask their local DNS server of their internet service provider, what is the IP address of myshop.ie, what is the A record there, and the ISP DNS server will first have a look at whether it has the DNS record cached from before. If it does, it's also going to check the TTL. You know, do I have it cached for more than 1 hour? If I do, then I have to ask Black Knight what is the current IP address, right? So this affects the propagation of your DNS records through the internet. Because if you have 1 hour there, then you need to count with the fact that around the world, the old DNS record, even though you've changed it for a new one, is still going to live for up to an hour before everything gets refreshed from the source, which in this case is Black Knight. Just a quick note, some ISPs do cache DNS and they choose to ignore TTL, because TTL is just a value. They can listen to it, or they can't, or they don't have to, right? So in some cases it may happen, just in case that, okay, you've set it for 1 hour and 2 hours ago you've changed the DNS, and for the client it's still pointing him to the old server. This is what it can be, right? And the last thing, just a quick note, that the name server change is separate to the DNS records, right? You can see that in our case here, all the DNS records are with Black Knight, but not the name server records. They are with the wherever the domain is registered, in this case GoDaddy, right? Okay, so we're done with this one now. Let's go back to here and switch to the next. Okay, so that's the global structure here. There are thousands of DNS servers around the world. It's a distributed database model, and the name servers are the nodes. On the map on the right side, you can see this is a screenshot from the dnschecker.org, where you can see the global propagation. Naturally, this is only a tiny subset of all the DNS servers out there. These are just the DNS servers that are in control of dnschecker.org. Just so you don't think that this is everything. So even though you have all the ticks here telling you that yes, your DNS has propagated already, might not be the case, right? And as I said before, each ISP, internet service provider, that you're connecting through to the internet, they provide their own name servers to their clients, to you, to our office, wherever. And also bigger companies have their own DNS servers, usually in-house. Most of the big companies have their own proxy servers and DNS servers, and they may have weird rules set up in terms of how often the DNS records refresh for their local network. So what that means is that if we're doing a DNS change for them and it doesn't seem to propagate, this could be why, because they may have a DNS server in-house which is just refusing to accept anything new from the outside. It has it cached, it knows best, so it's gonna keep bringing people to the old website even though you've made your change yesterday already, right? And it can do this for weeks unless this is pinpointed and in one case I had to ask them, talk to your IT, see if this is the case. And if they didn't, we wouldn't have figured it out. Of course, each domain name has an authoritative name server. So that is the name server where the DNS is actually hosted, right? The DNS of a particular domain sits on basically all the DNS servers around the world, right? But only one is authoritative. That's the one that is the king for the specific domain, or multiple of them. So that's maintained by domain administrators. That's Black Knight and us, for example, right? Because we have the power to change it on Black Knight in the name of our clients. So other DNS servers across the internet, your ISPs replicate and cache the DNS records on demand. So whenever somebody asks a specific DNS server for a specific DNS records, if the DNS record is not cached by that DNS server, it's going to ask the authoritative DNS server for the information, and the DNS server is going to cache the information for other people, so it doesn't have to keep pinging the main central server with every single request, right? And it's gonna store it based on the TTL, as I said before. So it can store it for up to an hour, up to a day, up to 2 days, whatever you have set up. So generally, it's a good idea when you know that you're going to go live tomorrow with whatever domain name, you know that you need to switch the A records. a day before, you can just go to the old DNS record and change the TTL for, to 5 minutes, just to make sure that tomorrow it's just going to switch very quickly, right? So obviously that affects the propagation speed across the world, because the DNS server around the world will notice the TTL change. They're gonna cache it for 5 minutes only, and they're gonna ping the authoritative DNS server more often this way. But since it's gonna only last a day, and then you're gonna put it back to whatever, 1 hour, then you're fine. Non-authoritative DNS servers refresh their that should be cache by querying our authoritative DNS servers when TTL expires. That's what I just said. Okay. So this is your typical DNS workflow. It's just again the same thing that I've already said, but just this time a more visual. So you can see that we have the client browser here. We have the host file. We have the name server of my internet service provider. We have the domain registrar, which is GoDaddy in our case. We have the authoritative name server, which is the Black Knight, where the DNS is hosted, and we have the web hosting server on the very right side, right? So a new user comes along, puts matrixinternet.ie in their browser, and the first thing, as we already know, the first thing the browser does is it's going to check the host file. Is there a line for matrixinternet.ie? Do you have an IP address that I can use it? If no, fine, it's going to ask for the DNS record. It's going to ask your local ISP name server. Is there a DNS record? Do you have an IP for me? If no, if the answer is no, or the TTL is expired, then your client browser is basically waiting. It's still waiting for an answer from your DNS server of your ISP. In the meantime, the DNS server is going to check with the domain registration server and it's going to ask the question, who is the authoritative name server for this matrixinternet.ie domain name. And the domain registrar says, okay, this DNS is hosted on blackknight.com. Fine. So the ISP name server now knows who to ask for the correct DNS record, and it's going to do that. It's going to ask the Black Knight name server, do you have the IP for matrixinternet.ie? Yes, it does. It returns it back. It's going to cache it for as long as the TTL says so. And then it's going to finally return the IP address to your browser. Now the browser finally knows where to search for matrixinternet.ie, and it's going to ping the request over to the hosting server of the correct IP address, and the hosting server sends back the HTML file with Bernard's hairy hand over here, right? So this is a somewhat different topic. Content delivery networks. As you know, we use CDNs for certain bigger websites, and the main reason for CDNs is obvious from the image on the right side. So you can see that it's split in the middle, and on the left side, that's how this works with no CDN. So the scenario here is that you have a website hosted on a single server. And what that means is that everybody from around the world, if they want to load the website, they need to go, their request, and then the HTML data itself need to go all the way to the server, and then all the way back across multiple hops throughout the global network, right? So that's going to take time, and then it needs to download your HTML, your CSS, your images, your videos, whatever. That's all going to take some time if the website is hosted on a server in a specific one location in the world, for obvious reasons. So that's going to have an impact on the loading speed globally, right? And of course, the further away geographically you are from the hosting server, the worst loading times you're going to experience. So that's when the CDN, content delivery network, kicks in, and what it does is it takes over the hosting of static assets. So that's your images, that's your JavaScript, that's your JPEG, CSS, your videos. and it is going to take a copy from the central server, and it's going to host a copy of all these files across multiple servers all around the world. And then if somebody from Russia, somebody from the US or wherever want to load the website, yes, the text is still loaded from your server, but the heavy stuff is loaded from the server that, on the CDN network that is closest to your location, right? I hope that makes sense based on the image here. And the obvious problem here is that in order for the CDN to be able to serve images, JS, CSS from your local server and still allow the actual content, text content, and the code to be served from the main hosting server in Ireland, for example, then you have a problem there because you only have a single domain name, and your browser needs to know to go to one server for the static assets and another server for everything else. So there are two possible solutions to this problem. Assets can be hosted on a separate domain name, which is, Lubos, what you've asked me before the call. So that's how you can tell just by looking at the code that there is a CDN installed on the website, because the images, if you open a specific image on a specific page in a new tab, you're gonna see that it's being served from a completely unrelated domain name to the domain name of the actual website, right? So that's how you can get it to work. But if you want to integrate the CDN properly, then you need to give the CDN control of your A records, right? And what the CDN can do this way, when it has control over the A records, is that it can serve different people different A records based on where you're from, right? So if there is a, you know, the way you get the HTML from the server and the browser is starting to fire out requests for your image in the header, then the image in the footer, and then the video. They are all separate requests, right? And they go through the CDN. So for every single request, the CDN can decide, okay, this is an image that I host, so I'm going to give you the IP of my server. Okay, this is a request for something that is not static, right? So I'm going to give you the IP of the hosting server. And it can fiddle around like this and make sure that you're being served the static assets from the CDN network, from the closest server to you, like on the image here, while everything else is being forwarded on to the central hosting server there, right? Aside from CDN, there are different approaches how you can, ensure that your app or your website works globally. For example, Amazon AWS has a different way to do that. You can have different central servers actually, all around the world, in which case you may not need a CDN, but we're focusing on a CDN solution now here, so that's how that works. Brian, do you want to add anything on top of it? I know that you worked with the Key CDN, which is a new one for us. I worked with CloudFront before, and we have someone on Cloudflare as well. All of these things work along the same lines, but there are some differences. Do you want to add anything to it?
Yeah, so key CDN, by default, we just look at that as a traditional CDN, which is just for serving the static files closer to where the person is, right? They will give you a default domain there, which will be like, xyz dot or cdn.xyzkeycdn.com, and that's where they'll be served from. You can create zones in there, so the zones will map to the user's own domain. So it means you'd have to set up a subdomain record or a CNAME record in the user's domain area, like cdn.foxford.com. Then you need to create an appropriate zone and map that record to the zone once it's been updated, right? So that it looks like it's being served from their own CDN. And we have Key CDN set up in that way. We don't have it mapped to foxford.com. It doesn't really matter. Then with Cloudflare, it is very, very different. So Cloudflare is the kind of thing where it is, as Thomas said, it's a CDN proxy, right? So with that in mind, what what Cloudflare actually does is it allows you to proxy the DNS records. So you don't have to just have those. It also allows us to change the way the files are served. So we can enforce HTTP2. We can control TLS for encryption on Cloudflare. We can minify all the CSS. So sometimes if you're using WP Rocket and you minify JavaScript, CSS, and HTML on WP Rocket, it will break shit, right? But if you actually do that on Cloudflare, it doesn't have the same impact. It minifies them, but it doesn't actually affect the way they work. I don't know how they do it, but it's really, really good. And also then that you do have page rules in something like Cloudflare. So Cloudflare is really good. So you can actually cache everything on a specific page in Cloudflare and set the cache TTL for, like, let's say 8 hours. But it caches absolutely everything, and that allows you to deliver a homepage really, really quickly. So there's a lot of additional features in the DNS proxy with all those caching systems that are enabled. And the likes of Cloudflare has additional things like Mirage and Brotli and all these different things that we can just enable with the click of a switch, rather than going through and having to install all these via SSH on a server. So really good, worth looking into. We have multiple websites on Cloudflare. The free version, you can use the free version of Cloudflare as long as you put the DNS records up on Cloudflare and leave it be the authoritative controller of the DNS records up there. You can proxy some records, other records cannot be proxied. You have to put them in place. If the client does not want to transfer their DNS control, so if they don't want to move it from GoDaddy or from Black Knight, then they do have an option. You can enter a CNAME record. So rather than changing the name servers, you can put a CNAME record in place in Black Knight or GoDaddy that allows you to use Cloudflare. But that puts you on the enterprise level plan, so it's $200 a month. So we've not had any clients who want to do that yet, but it is an option if you're talking to people.
Brian, right? When you say DNS proxy, can you explain that?
So you can proxy the DNS records. So certain records can be proxied. Certain records have to be entered by default. So if you're putting in direct records like an A record, because it's coming through from the original, DNS controller, it can only be proxied. Okay, it has to be proxied. Whereby Cloudflare, in essence, are, even though you're using their name servers, they're kind of pushing that record update back to the original domain controller. It's a very unusual way, but you'll notice that in Cloudflare, when you're trying to do this, that some of the records you try to enter, if it doesn't allow you to enter them, then you're not allowed to proxy those records. They have to actually be entered directly into Cloudflare. It's really only an issue, Thomas, if we're using the free version.
Okay, very good.
Okay.
Thanks for that.
Mm-hmm.
Okay, so some DNS tools, right? In some cases, when you're trying to help the client to resolve an issue, you may need to have the information of, where the DNS is hosted. In some cases, you log into our Black Knight, you find the domain name there, you find the DNS hosting there, you can see a bunch of records there. You go on to change the records, but the change of the DNS records doesn't take place. So why is that? Maybe it's because Black Knight is not the actual DNS host, right? Maybe the DNS hosting is there, but the name servers don't point to Black Knight. So it doesn't matter what you do there, right? In some cases, you need to know where the website is hosted, what IP address and which provider, where the emails are hosted, same thing, or where the domain is registered, right? So these are the three online tools that I normally use. DNSchecker.org, we're pretty much all familiar with. It can help you to look up any specific DNS record at all for a specific domain name. It can help you to find a host of websites, emails, and DNS, because you can list the name server records there as well. And by taking the IP from the DNS checker, if you don't know where a website is hosted, you just look for the A record, and then you can use the iplocation.net to transfer the IP address of the server to, it kind of gives you more information where the server is in terms of what country, where it sits, and also the name of the network. And in vast majority of cases, the name of the network will be the name of the provider. And the last thing is, this is a good WHOIS search. There is lots of Whois tools out there, but back in the day, it kind of gave you the information of who is the owner of the domain and who is the registrar of the domain. In our case, that's GoDaddy or our Black Knight or whatever, right? But it no longer gives you the owner information due to GDPR. They are just hiding everything now, right? So just a few examples. DNS checker here, matrix internet.ie. You can get the A record. When I copy the IP address over, I can log into I can search for IP to location. That's my IP location.net here. This is actually my own information here right away, and I can look up the IP, and I see that it is something weird. What actually is that? Where do we host our website, huh? Yeah, normally it gives you a little bit better information. Let's try something else. We're not very lucky right here. DNS checker, foxford.com. Let's see if that's any better. It doesn't always let you figure it out. Sometimes it does, and in this case you can see that it's on a DigitalOcean, right? So that's the name of the ISP. They have their own connection, of course, because they are a big data center, right? So that's how you can tell which platform hosts the website. If you do the same for the Amex record, yeah, actually they use this. You can Google for this and figure out where who the email host is, right? And the last thing was the Whois search here. So again, matrix internet.ie, Whois lookup, and this used to be a much better tool back in the day because it actually gave you the name and the email address, sometimes even phone of the owner, which is useful information, but at least it gives you the registrar. In this case, you can see that the domain is registered with Black Knight, so you know that Black Knight is responsible for registration of the domain in case there is some kind of a dispute or you don't know where to go. Okay, and that is it. That is it. So I'm going to pause the... any questions, first of all? Anybody at all?